Good evening, everyone. My name is Niketa. I'm a PhD student from IIT Madras, Department of Chemical Engineering. I'm the TA for this course, Industrial Wastewater Treatment. And welcome to the week 10 of the live session class. So, before we start, do you have any questions from this week's or the previous week's lectures? Any questions from or any doubts from the previous week's lectures? Yeah, good evening. Okay, so what we will do in this class is I'll give a brief of some topics from week 10 lectures, and then if you have any doubts, you can ask me by the end of this class. Alright, so let's proceed. So this is week 10. So this week you would have seen the lectures about iron and steel industry. So the iron and steel industry is about producing steel and iron. So the first process that happens is coal mining. So the first process is coal mining. Now, the reason why we do this is because since we are going to operate furnaces, we need fuel for it, and coal is the that fuel. So, after mining the coal, it is crushed, screened. Now, screening is done to separate different particle sizes. So, from smaller pieces of coal to big pieces, so that can be separated in screening, and then washing. So washing is done to remove any impurities that are there. So why this is important is when we burn coal for generating heat. So if it contains any a high amount of impurities, then there will also be a high amount of ash. So to avoid that, we are doing washing. So generally, when coal is washed, it produces some effluent. So in the washed water, it could have a high amount of suspended solids. Yeah, so coal wash water can have a high amount of suspended solids, and also when the coal is pyrolyzed by pyrolysis. So can you tell me what is pyrolysis? What is pyrolysis? No, actually, pyrolysis is heating the absence of air. So during pyrolysis, we don't give any oxygen, so the coal does not get oxidized. But what happens during coal pyrolysis is that it releases a lot of VOCs or volatile organic compounds. So that's fine, it's okay. We're all here to learn. Okay. The next step is quenching. So quenching, basically quenching is like reducing the temperature by adding water. So we bring down the coal temperature by adding water, and this process produces spent ammoniacal liquor, phenols, cyanide, and ammoniacal nitrogen. Alright, so this was all about coal. So the coal is first mined and then it undergoes a series of processes like crushing, screening, washing, and then it is pyrolyzed. And during pyrolysis, volatile organics are released. Basically, they are organics which get volatilized or vaporized at a high temperature, and then the coal is quenched. Right. So the next step is blast furnace. So here the iron is reduced. So iron reduction happens here. And blast furnace is the place where a lot of dust is produced because this would have ash, which is both settled ash as well as the fly ash. And whatever dust is produced can be removed using dust catchers. So the next process is steel smelting. And then hot rolling. And pickling. So hot rolling produces about 7,000 liters of wastewater per ingot of iron, per ton of iron. So 7,000 liters per ton of iron. So it releases so much of wastewater. And pickling effluent will have a lot of acids and heavy metals. Right, so let's come to the different types of wastewater. So the first one is water from coal washing. And also from blast furnace. So the water from coal washing and blast furnace will have a lot of physical sediments. So physical sediments are particles that settle down after some time. So because this is wash water contains a lot of suspended matter, and that's what this physical sediment means. And second one is toxic water from coke ovens. So it has a high amount of chemical pollutants. So on average, iron and steel industry, just writing it shortly. So iron and steel industry produces 5,000 to 6,000 milligram per liter solids. So usually the wastewater that's coming from iron and steel industry has a concentration of 5 to 6,000 ppm of solids and about 1,400 ppm. ppm and milligram per liter are one and the same when used in for water. So the concentration of nitrogen is about 1,400 ppm or 1,400 milligram per liter in coke oven waste. So now coming to the impurities in coal. So there are two types. The first one is the fixed impurity and the second one is the free impurity. So the fixed one can be removed using thermochemical or thermal processes. And the free impurities can be removed by washing. So washing is a physical process and thermochemical or thermal is a chemical process. So fixed impurities are removed only thermochemically or thermally, whereas the free impurities can be removed just by washing. Okay, so whatever the effluent comes from coal washing contains a lot of suspended solids. And we have studied what methods can be used for removing suspended solids. So can you tell me which one? What method can be used for removing suspended solids or colloids? So what method is used for removing suspended solids or colloids in water? Yeah, using alum, yeah, correct. Alum is a chemical. And what is the name of the process? What is the name of the process where alum is used? Okay. Yeah, so the name of the process is coagulation and flocculation. Yeah, so alum is the coagulant used, the more popular coagulant. So, yeah, for removing suspended solids in coal wastewater, coagulation and flocculation is used. Right, so next we come to the coke oven. So hard coke is produced by heating coal at 1,200 to 1,300 degrees Celsius for 15 to 16 hours in absence of oxygen. When this is done, we get hard coke. So since this is in the absence of oxygen, there is no oxidation that's happening, and most of the organics will escape as volatile gases, and these gases can be trapped recovered and used as fuel. So so that can considerably reduce the energy expenditure. And once this process is over, quenching is done. So quenching can bring down the coke temperature to atmospheric temperature. So once the heating is done, the first step is heating, the second step is quenching. So let's look at the types of coke oven plants. So the first one is non-recovery plants, and the second is recovery. So this is based on the materials that can be recovered. So if there is recovery done, then it becomes a recovery coke plant. If it is not done, then it is a non-recovery coal plant. So by recovery, we mean recovering chemicals like phenol, ammonia, coal tar, naphthalene, and benzol. But the only drawback of this process is that it is highly expensive. So much so that industries prefer buying these chemicals fresh from the market rather than going for a recovery process. Okay, now coming to the wastes. So coke oven on average produce about 400 to 500 liters of wastewater per ton of coal. And if it is discharged as such without any treatment, it can affect the taste and odor of drinking water. And it can also cause problems because of oil slicks. So, can someone tell me what is an oil slick? What is an oil slick? What's an oil slick? So as the name suggests, it's got something to do with oil. So oil slick is basically, a layer of oil that forms on top of water. And this is especially relevant when we talk about oil spill or oil spillage that happens in oceans. So imagine there is a oil tanker that is being transported from one place to another place, and it's in the middle of the ocean. So something happens, and there's a leak in the tanker, and then oil starts coming out. So then it forms. Imagine this is the water surface. So forms patches of oil that just floats on water. So and this is you know highly dense oil, not the regular oil that we use at home. It is quite thick, so it is sticky and thick. So this oil layer, it's very difficult to remove, and over time what happens is, if there are any fishes nearby, they swim near the oil slick or near the places with oil, their fins get coated with oil. So once their fins are coated, their gills are blocked, so they cannot breathe and they eventually die. And even for aquatic plants, once the oil slick forms, it blocks the sunlight. So the sun rays are completely blocked from entering into the water. So if there are any oil slicks, so then the aquatic plants inside, they just die. So it also prevents the oxygen transfer from inside to outside. So there is no oxygen, there is no sunlight. Obviously, the aquatic life gets affected. So that's what that's what happens if there is an oil spill, and the formation of this floating oil layer is called an oil slick. So if we discharge the coke wastewater untreated, then there is a chance that it could form an oil slick and could kill the aquatic plants and animals. Alright, so the BOD limit for discharging coke wastewater is 30 ppm or 30 milligram per liter according to the Bureau of Indian Standards or BIS. And it is 25 ppm. We're talking about BOD. According to US EPA or the US Environmental Protection Agency. Right now, coke ovens also generate coke oven gas. So this coke oven gas, it contains a lot of aerosols. So what are aerosols? No. Right. So aerosols are solids in air. So just how we have a solution, solids dissolved in liquid. So similarly, solids dispersed in air are called aerosols. Now, the coke oven gas contains a lot of aerosols, And if we just let them be, they can choke pipelines. So we have to prevent that and remove the aerosols before discharging the coke oven gas. And it also contains ammonia. So ammonia is removed using wet scrubbing or catalytic cracking. So catalytic cracking means using a catalyst to break down ammonia into nitrogen and hydrogen. So again, a catalyst is something which does not participate in the reaction but which helps in the reaction to proceed. So we use some catalysts to break down ammonia into nitrogen and hydrogen. And we can also recover light oil to capture BTX. So BTX is short for benzene, toluene, and xylene. So these are also organic pollutants which are of concern. So they can be captured. And then desulfurization is done. Using processes like vacuum carbonate or ammonia wash or sulfibin process. So yeah, these are the processes or steps in the coke oven for treating gaseous pollutants. Now let's come to liquid effluent. So for treating liquids, we can go for physicochemical, and biological processes. So physicochemical processes include air stripping. So air stripping is done for ammonia, and we can also use some advanced oxidation processes or AOPs for toxic compounds. And biological, we can use activated sludge process. For removing organic matter. And cyanide is removed through alkaline chlorination. Now, if we have integrated wastewater treatment, then first we have to go for equalization. So equalization tank will average the flow and the concentration of the effluent. And then the second one is denitrification. The third step is two-step aerobic biological process to remove phenol. and reduce BOD and COD. The fourth step is nitrification, where ammonia is converted to nitrate. The fifth step is using a settling tank to remove silt and refractory compounds. And coke industries are required to follow zero liquid discharge norms or ZLD norms. So called ZLD. Now, ZLD means there are no liquid effluents that are coming from this industry. So, in order to be one such industry, whatever effluents are coming, whatever wastewater is coming, it needs to be recycled back. That's what's being done here. So, the treated effluent is taken back into the plant and used for various purposes, like maybe for cooling or maybe for sprinkling. So, okay, so the next industry is the crude oil industry. Okay, so first let's start with what is crude oil. What is crude oil? What is crude oil? Where is it used? Right. So we are in a crisis right now. The whole world is facing a crisis because of crude oil. So this is very relevant right now. And yeah, crude oil is used to make a lot of products, including petrols, diesel, um, natural gas, compressed natural gas, and so on. So that's the main use of crude oil. And in a crude oil industry, so basically, crude oil means a complex mixture of various types of hydrocarbons having different molecular weights and structures to produce LPG, liquid petroleum gas, gasoline, diesel, and bitumen. Right, so let's look at how a refinery operates. The first step is topping or skimming. So this means heating at different temperatures or fractional distillation. So have you heard of fractional distillation? So fractional distillation basically means heating at different temperatures, and at each temperature, the corresponding volatile gas comes out. So that is fractional distillation. And then there is cracking. So cracking produces, cracking is for heavy crude oil that does not evaporate. So after the topping or skimming method where fractional distillation is done with crude oil, whatever is left over, that is the heavy crude oil. It doesn't evaporate. Now, this heavy crude oil needs to be cracked. So the cracking is done using thermal and catalytic methods. So thermal is applying high pressure and temperature. So this produces a residue called coke. And catalytic is using catalysis, of course, or some catalyst. So here the petrol is, high temperature is applied in the presence of a catalyst, and we produce lighter products. And the third step is catalytic reforming. Okay, So catalytic reforming converts naphtha into high octane gasoline. Let's come to the wastes that are produced in refineries. The first one is using desalted water from washing raw crude. And the second type of waste is sour water from steam stripping and fractionation. And the third waste is spent caustic. Now, caustic is also called as alkali. So, spent alkali is used for extracting acidic compounds. And then tank bottoms. So, tank bottom means sediments and water settled over a period of time. So, whatever sediments and water settle after some time is called as tank bottom. And then the cooling water blowdown. And the condensate blowdown. Okay, so these are the different types of waste that are produced in refineries. Okay, coming to the treatment methods. The first one is using physical. Physical methods include gravity separation, now can someone explain what is gravity separation? What is the principle behind gravity separation? It is a type of separation, but then what is the principle behind it? What is gravity separation? what is gravity separation? What happens during this process? Right. So, as the name suggests, gravity separation has something to do with gravity, right? So, it means separating substances based on their mass or weight. So, heavy substances go down and lighter substances come to the top. So, based on their mass, and gravity just acts on it. So, this is gravity based separation. So, this is done to remove any free oils, any lightweight oils. So we don't want oils to be involved in the treatment process. So that's why it is important to skim or use a gravity separator to remove oils. And then the chemical process. So chemical process involves coagulation and flocculation. So can someone explain what happens in coagulation and flocculation? What happens during coagulation and flocculation? So we've already discussed this many times, so I hope all of you remember what this means. So what is coagulation and flocculation? We discussed this today also. Someone said alum. So alum is the coagulant and coagulation flocculation is the process. So I want you to explain what happens during coagulation and flocculation. Okay. So coagulation and flocculation means if there are suspended solids and those solids repel each other because of like charges, so we add a coagulant, and a coagulant's main function is to ensure that the charge layer gets reversed. That is, if there is a layer of positive charge, then a layer of negative charges developed on the surface. So this can attract particles of positive charge. So that's the main function of a coagulant. So yeah. And flocculation means basically just mixing. So mixing to ensure that flocks form. And as they form, their weight increases and it becomes easier for them to settle down. Right. And this is obviously followed by sedimentation. So sedimentation is where we allow the flocks to settle down. The third process is biological. So in under biological we have activated sludge process. So can someone tell me what activated sludge process means? What happens in this process? What happens in activated sludge process? Right. So in activated sludge process, a portion of the sludge is recirculated back into the system, so that it can provide a source of microbes for the degradation. And we also use aerated lagoons and trickling filters. So trickling filter is it's not a I mean it's not a suspended process. It's an attached root process. And in aerated lagoon, we allow the wastewater to degrade in an open area, in an open space, with sometimes with aeration. So aeration is provided externally. So and then the degradation happens. So if we go for an integrated treatment, the first process would be having an equalization tank. The second is dissolved nitrogen flotation. The third would be adding nitrogen and phosphorus to maintain a proper carbon nitrogen phosphorus ratio. So if there are insufficient nutrients, then the microbes cannot degrade the waste. So that's why it is important to add nutrients if they are lacking. And the last step is also known as the polishing step. So for this, we will be using filtration. So whatever sludge Okay, so because it's a biological process, so there will be sludge production. And if there is sludge production, then that is treated as hazardous waste because this is coming from pork oven. So pork oven could contain a lot of hazardous chemicals. Like we just saw BTX, right? Benzene, toluene, xylene. So the sludge could also contain these chemicals. Along with it, it can also have oil and grease. So together, it becomes a hazardous waste that needs proper hazardous waste treatment before it can be disposed. And if it still remains as a solid, it should be at least stabilized. So once it is stabilized, it can be landfilled. So landfilling is like basically uh, taking the waste and making a landfill like this and ensuring that there is proper lining with waterproof material and then placing the waste in blocks, multiple blocks, one by one, layer by layer. And then finally, as this becomes full, it is covered with a layer of soil. And sometimes plants will be allowed to grow on top. And even at the top, there is waterproof layers. So this is to ensure. I'm extremely sorry. So yeah, so I was just saying that the sludge that is produced, because it is a biological process, so sludge will be produced. So whatever sludge is produced, that is hazardous waste because it could contain toxic chemicals like benzene, dilenes, toluene, xylene, BTX, and it could also contain oil and grease. So oil and grease is also toxic. So together, these two become hazardous waste. And something which is hazardous needs to be treated as a hazardous waste, meaning it cannot be combined with any other solid waste. It needs to be taken to a hazardous waste treatment facility where it will be stabilized first. So once it is stabilized, it will be taken to a landfill. And this here is a diagram of a landfill. So landfill is basically soil which is excavated to create this kind of a structure, and whatever stabilized waste is there, that is placed layer by layer at the bottom, and then it is filled continuously. And also the soil layer will at the bottom will be lined with lining material like HDPE to prevent water from percolating through, and the top will be covered by soil, and also it will have a layer of waterproof material at the top, so that will prevent any rainwater from entering into the landfill. And on top of the soil layer, sometimes plants can be grown. So alright, so when we talk about integrated treatment, so Equalization tank. So equalization tank is used for maintaining a uniform concentration. So I'll write it down here. It is used for maintaining uniform flow and also to avoid shock loads. So shock load is when the treatment plant is not designed for getting a very high flow rate. So in that case, shock loading happens and the system collapses completely because the various unit operations and processes, their units are designed for only a certain capacity. But if the flow is much higher than that, then it is not possible to accommodate it. So in that case, we use equalization tank where it is stored for some time, and then when the flow is low, so the extra wastewater flow that has come is let in, and this is done to maintain a uniform flow rate throughout. So yeah, that is the purpose, and also for making the concentration uniform throughout. And yeah, the next step that we saw is dissolved nitrogen flotation. So, dissolved nitrogen flotation means so nitrogen gas is purged. So, purging means to constantly allow a flow of gas into the liquid so that it becomes saturated with the gas, and this is helpful for releasing the oil emulsions. So emulsion is basically a solution of oil in liquid. It could be water or anything. So usually one very good example will be milk. So milk is an emulsion. So that is why we use a churner, or like for making butter we use a churner. So when we churn the milk or the curd, so what happens is that the mechanical action forces the oil to come out from the emulsion and float at the top, and then butter is collected. So here also agitation is introduced by the action of gas bubbling. So here it is nitrogen gas bubbling, which is more effective than centrifugation. So what it does is it separates, it creates a friction. It separates the oil from the water, and it maintains a layer of oil on top. So if this is the emulsion, so this maintains a clear layer of oil on top. Oil, or it could also be grease. So this oil or grease layer is then it is skimmed off. So we use equipments like skimmers. So skimmers generally they like they are just going to. If this is the surface of the oil, and we just allow the rest of the water to flow, and we have a skimmer in place here. So this just collects whatever oil comes, and the rest of the water just flows away. So that's like skimmer. So the nitrogen is used for breaking down of emulsified oils. And then the oil floats on the surface where it is skimmed off. So after this, what happens is that we add nutrients like nitrogen and phosphorus to maintain the proper CMP ratio. So why is this done? So nitrogen and phosphorus is added to ensure that sufficient nutrients are available for microbes to break down. So once that is complete, we go to the next step, which is biological treatment. So the usual treatment that is done is aerobic biological treatment. So aerobic biological treatment can be ASP or like trickling filter, so on, like what we have already discussed. And this helps in reducing BOD and COD. And the next step is the polishing step. So the filtration is done as a polishing step. So what it does is, if there are any solids that are remaining even after undergoing all these processes, usually there will be some solids like could be some organic solids, some very fine particles that are floating on the surface or that are floating in the as a suspension. So this needs to be removed because unless it is removed, it cannot be discharged. So that removal is done using filtration. So there are different types of filtration. There are different types of filters, like we have reverse osmosis, microfilters, and even some big filters like slow sand filters or rapid sand filters. So we have filters of various pore sizes uh, to remove solids. So we can use one of those for this purpose. So after all these steps, the final step is discharge. Discharge meaning the water is allowed to pass through and it is discharged into a river or a lake or any surface water body, or it can even be reused. So whatever sludge is generated, like we already saw that it is treated as a hazardous waste, and for treating the sludge, we first do sludge dewatering. So sludge dewatering means to remove excess water from sludge. So this is done to ensure that there is no interference of water during the sludge stabilization process. So we need to have dry sludge by the end of the treatment process. So that is why the first step is to remove any excess water. So that is done by using filters or filter presses, centrifuges, so all of that. So that comes under sludge dewatering. And once the sludge is treated, it is disposed. So disposal is what we saw here. using it is treated as a hazardous waste because it could contain toxic substances, so it is usually landfilled. Now let's see the oil separation process. So it is designed by the American Petroleum Institute. So the separator that is designed by API, it uses differential gravitational settling. Differential gravity settling. So this differential gravity settling is separation based on the weight or gravity of the various substances. So in here we have an inlet tank, and from the inlet tank a conveyor belt is used. That moves oil to the surface. So once the oil comes to the surface, we use surface skimmers to remove oil, and once the oil is removed using surface skimmers, so they are then transported to pipe skimmers. So these pipe skimmers are basically like pipes which collect the skimmed oil, and they are transported. They are transported away from the water. And once the skimming process is complete, like whatever oil was there, it is skimmed off and it is transported away using a pipe skimmer. So the remaining wastewater, whatever is there, which is clarified, so the clarified water moves to the outlet tank. So once it reaches the outlet tank will have structures called baffles. So baffles are basically like if there is a tank like this, and imagine this is the, I mean, if the wastewater is coming this way, so inlet is somewhere here, and the outlet is here. So if the wastewater is coming in this direction and it is allowed to pass through, so in between we have a structure called a baffle. So the purpose of having a baffle is so that usually if there are any solids that are present, so if there are any solids that are present, so any suspended solids actually, so these suspended solids, they get stopped at. So this is a baffle wall. So these so they get stopped here. Whatever solids are there, they get stopped, and only the remaining water, which is clarified, will flow over this. So the flow is actually kind of restricted here. So let me redraw this. The water flow is actually like this. So this here is the baffle wall. So any water that is free of solids is allowed to flow up, and whatever solids are there, they get restricted from flowing out. So yeah, this is the baffle wall that is provided. So this is the design of this is the principle behind the American Petroleum Institute separator. So overall, in this process, what happens is that an equalization tank is provided for to ensure that the flow is uniform. And after that, the next step is to remove oil, to separate oil from the emulsion using dissolved nitrogen flotation. And whatever wastewater is there to it, we add appropriate amounts of nitrogen and phosphorus, because if the nutrients are lacking, then microbial degradation will not be very effective. And then we go for biological treatment. We mostly use aerobic biological treatment, and then the treated water is allowed for given out for discharge. And then we saw how sludge treatment is done using dewatering, and then finally the sludge is treated as a hazardous waste and it is disposed in a landfill. And then we saw how an API separator is designed. So yeah, we've reached the end of this class. So thank you all for joining.